In this video, you will learn how to derive some functions using the chain rule. I've already discussed in the other video what a chain rule is, its formula, and how to derive a function using it. Now let's solve some problems. Now we're given this function y equals the square root of x plus the square root of x plus square root of x. Now to find the derivative of dy over dx, we can use the chain rule and implicit differentiation. So let's recall what a chain rule is. So dy over dx is just equal to dy over du times du over dx. Now to solve this, we have to define u first. And in this case, we have multiple expressions here. So we have inner expression square root of x, and then square root of x plus square root of x, and then square root of x plus square root of x plus square root of x. So we can let u be equal to the square root of x, and then we let's say v equal to the square root of x plus u, or this is just simply equal to the square root of x plus square root of x, this one. So we let u this one first, and then this one v, and then for y, the whole thing, this one. So this is just the square root of x plus v, which is just equal to the given function, which is the square root of x plus square root of x plus square root of x. And now let's differentiate each of these step by step, or one by one. We need to differentiate the outermost function first. So the outermost function is the whole thing, this one, the square root of x plus square root of x plus square root of x. Right, so we have here, we already let y equals x plus v. So we can differentiate dy with respect to x. So that dy over dx is just equal to the derivative of square root of x plus v with respect to x, and this is just derivative of the square root of x plus v. We can write that as x plus v to the 1/2 with respect to x. So this is just equal to 1/2 times x plus v to the negative 1/2 minus 1 times, alright, let me change it, times the derivative of the inside function, or expression, which is x plus v. So derivative of x plus v with respect to x. So this would become 1/2 times x plus v to the negative 1/2 minus 1. Oh, it should be 1/2 only. So 1/2 minus 1, which is just negative 1/2. Then derivative of x plus v is just 1. Derivative of x is 1 plus derivative of v with respect to x. Therefore, dy over dx is just equal to 1/2 times x plus v to the negative 1/2. We can write that as x plus 1 over x plus v to the 1/2. So this is just 1 over 2 times x plus v to the 1/2, or just simply the square root of x plus v. X plus v times 1 plus dv over dx. Now we have already derived this one, the outermost function. So let's write that here. Now, the next function that we're going to derive is v, function of v. And v is equal to the square root of x plus u. So to derive that, derive dv with respect to x. So this is just the derivative of square root of x plus u with respect to x. And this is just simply, we can write square root of x plus u as x plus u to the 1/2 over dx. And the derivative of that is just 1/2 x plus u to the 1/2 minus 1 times the derivative of this one, the expression inside the parenthesis. So that is derivative of x is 1 plus derivative of u is du over dx. And to simplify that, dv over dx is just equal to 1/2 times x plus u to the negative 1/2 minus 1 is negative, no, 1/2 minus 1 is negative 1/2 times 1 plus du over dx. And x plus u to the negative 1/2 can be written as 1 over x to the 1/2. Therefore, dv over dx can be written as 1 over 2 to the square of 1 over 2 times the square root of x plus u times 1 plus du over dx. Alright, we've already derived the function y and v, and now the last function that we're going to derive is u, which is equal to the square root of x. So du over dx is just equal to the derivative of square root of x with respect to x, or we can write square root of x as x to the 1/2. Then we derive that, so this would become 1/2 x to the 1/2 minus 1 times the derivative of x, which is 1. Okay, we'll just, anyway, we multiply that by 1. It will be just be 1/2 x to the negative 1/2. And we can simplify this as 1/2 x to the negative 1/2, or just 1 over 2 square root of x, because x to the negative 1/2 can be written as 1 over x to the 1/2, or 1 over square root of x. So now we already have du over dx. So let's write du over dx here. That is 1 over 2 square root of x. And now we can solve everything. We just have to plug back into the expression of dy over dx. Now dy over dx is this one, all right? So dy over dx is just equal to 1 over 2 square root of x plus v. Oh, let's recall u, v, and y. Let me write that here. So in the beginning, we let v as square root of x plus u, and then y equals square root of x plus v, and u equals square root of x. So we have here 2 times the square root of x plus v, so this is just 2 times x plus 2 times the square root of x plus v, which is just the square root of x plus u, times 1 plus dv over dx is this one. dv over dx is 1 over 2 square root of x plus u times 1. Alright, no more space. So let me just write du over dx here. So I can delete that. 1 over 2 square root of x. Right. So there'll be more space. So times, okay, 1, this one. 1 plus dv over dx. dv over dx is 1 over 2 square root of x plus u times 1 plus du over dx. So it's getting complicated now. Right. And now we can plug in the value of u and du over dx. So we let u equals square root of x, so we can just plug that back in here. So 1 over 2 square root of x plus square root of x plus u, which is square root of x, times this one. 1 plus 1 over 2 square root of x plus u is square root of x, times 1 plus du over dx is 1 over 2 square root of x. Then we can further simplify this. Let me just delete this so you won't be confused. Okay. So dy over dx is just equal to, right, we distribute that here, we multiply that here, so this would become, and then we multiply the entire thing here to 1, so this would become 1 plus 1 plus 1 over 2 square root of x over 2 square root of x plus square root of x. Okay. Let me delete this. All over, okay, all over 2 square root of x plus square root of x plus square root of x. So this is now the derivative of our function y. Now let's solve another problem. Now what if we're given this function x to the negative 1 minus 2x to the negative 2 to the negative 3. So to derive this, say this is a function y equals that function. So to derive this, we use the chain rule. So dy over dx equals dy over du times du over dx. Okay, again we choose for u. We let u be equal to x to the negative 1 minus 2 times x to the negative 2. So our function become y equals u to the negative 3. And actually, u here can be written as x to the negative 1 is just 1 over x minus 2 times x to the negative 2 can be written as 2 over x squared. And now let's derive the function y equals u to the negative 3. So let's solve for dy over du first. So dy over du is just equal to the derivative of y, which is u to the negative 3 with respect to u. So this is just negative 3 times u to the negative 3 minus 1, which is just negative 3 times u to the negative 4, or simply negative 3 over u to the 4. Now that we already have dy over du, then we solve for du over dx, which is just equal to the derivative of u, which is this one, x to the negative 1 minus 2x to the negative 2 with respect to x. Then we derive each of the terms inside the parentheses. So this is just the derivative of x to the negative 1, which is negative 1, times x to the negative 1 minus 1 minus 2 times, well, we use the power rule here, negative 2 times x to the negative 2 minus 1. And this is just negative 1 times x to the negative 2 minus or plus 4, because negative 2 times negative 2 is positive 4, times x to the negative 3. All right. So we already have dy over du and du over dx, and we can solve for dy over dx. We just plug in everything. All right. So let me delete this. Should be this one. Now let's recall our dy over du is just equal to negative 3 over u to the 4th, and du over dx is equal to the negative of x to the negative 2 plus 4x to the negative 3. Or we can just simply write this as the negative 1 over x squared plus 4 over x cubed. So let me delete that. Then we can plug in back the value of u, and then we substitute everything to the chain rule formula, which is dy over du times du over dx. So dy over dx is just equal to dy over du, which is negative 3, over u to the 4th. U is this one, 1 over x minus 2 over x squared to the 4th, times d over dx is negative 1 over x squared plus 4 over x cubed. Then we can further simplify everything. Wait, let me delete this. So dy over dx is just equal to negative 3. This one we can simplify this. 1 over x minus 2 over x squared. So we get a common denominator, which is x squared, divided by x is x times 1 is x minus 2. So this is just x minus 2 over x squared to the 4th. And this one, we can also simplify that. Okay, negative 1 over x squared plus 4 over x cubed. This is just equal to, we get the LCD, which is x cubed. X cubed divided by x squared is x times 1 is x plus 4. So this is just negative x. So x cubed divided by x squared is x times negative 1 is negative x. So this is times negative x plus 4 over x cubed. All right, and then we simplify everything. Then dy over dx would become negative 3. Well, we flip this. This would become x squared to the 4th over x minus 2 to the 4th times negative x plus 4 over x cubed. And this is just negative 3 x to the 8 over x minus 2 to the 4th times negative x plus 4 over x cubed. And then x to the 8 over x cubed. Since they have the same basis, we just have to subtract the exponents. So that would be x to the 8 minus 3, and that would be equal to x to the 5th. So minus 3 here, that cancels out. Therefore, okay, let me delete this. dy over dx would just be equal to negative 3 times negative x plus 4 times x to the 5th over x minus 2 to the 4th. Or you can write that as dy over dx equals negative 3 x to the 5th times negative x plus 4 over x minus 2 to the 4th. So this is our final answer. That's all for now. We will solve more problems on the rules of derivatives in the next videos.